Hello dear students, this is Asif Javed, your course instructor for calculus. In this video lecture, I am going to give you explanation of the examples. Dear students, I want all of you to know one thing, that I will be actually looking at the typical, or I would rather say those points in the examples which may cause problem for you guys, because rest of the things are quite easy, so I'm not going to give you detail of each and everything. So let us come to the first example. So far I have told you, I have given you a result that a limit exists if and only if, a limit exists finitely if and only if a right hand limit as well as left hand limit exists at a point, and both of them are equal. And more importantly, here we are going to use the epsilon delta definition, because it is asked that you have to use the epsilon delta definition of limit, and we have to prove, if you can see the cursor, we have to prove that this function 4x minus 5 has limit 3 at point x equal to 2. So as you know that in epsilon delta definition, I will repeat for one and all so that you are comfortable with this situation here. For any function f of x, we say that that function has got limit L at point A if what happens, if mod of fx minus L is less than epsilon for all x minus a, mod of x minus a less than delta. So if you see carefully here, the function fx is 4x minus 5 and your limit is 3. So we are interested in finding this mod of fx minus L. So if you find this mod, it will come out to be equal to 4 times mod of x minus 2. Now as we know that as far as the definition goes, it says that whenever this mod is less than epsilon, then we have to see that the delta that I will get, that delta must be depending on the epsilon as is required by the definition. So everywhere and now, whenever I will be looking at the limit of the function, then I will be looking at the difference of fx and L, and I will put that mod of fx minus L to be less than epsilon, and then I will look at what x minus mod of x minus a is going to be. That must be less than delta, and that delta must be depending on the epsilon. So here I am putting this mod of fx minus L less than epsilon. That gives me 4 times I have to, because if this mod of fx minus L is less than epsilon, what is your fx? This is 4x minus 5, and what is your L? This is 3. So when you will put all these things inside this mod, this will come out to be 4 times mod of x minus 2, and whenever I put this to be less than epsilon, I will get a condition on mod of x minus 2, and that is exactly the condition on mod of x minus a. So that is going to be less than epsilon by 4, if you can see it clearly. So that epsilon by 4 will work as delta. So for given any epsilon greater than 0, however small, we can find a positive number delta, and you can see that delta is depending on the epsilon, because that is epsilon by 4. So from here we can conclude what? That for all epsilon greater than 0, we have got a number delta depending on epsilon, such that whenever mod of fx minus L is less than epsilon, then mod of x minus 2 greater than 0 is less than delta. So that clearly says that the limit of this function, as we see from the definition of epsilon delta definition of limit, that the limit of this function fx at point x equal to a, which happens to be 2 here, this is going to be L, and so we have proved it. But more importantly, we have proved it with the concept of epsilon delta. Now the similar sort of example is here also. Here function is slightly different. It is x squared minus 9 by x minus 3, and we have to prove that this is equal to 6. We will proceed in the same manner. We will be finding the mod of fx minus L, and when we will find that, we will get mod of x minus 3. So mod of fx minus L should be less than epsilon. So that means, but mod of fx minus L is equal to mod of x minus 3. So that must be less than epsilon. So actually we are looking at mod of x minus a less than delta. So if you see carefully, you can choose this epsilon to be delta. So our definition is complete, because whenever mod of x minus a is less than delta, then mod of fx minus L is less than epsilon. So here we have done the similar sort of things here also, and our definition is complete, because mod of fx minus L is less than epsilon whenever mod of x minus 3 is greater than 0, less than delta. Now if you revisit the definition says that when this happens, then limit of the function fx at point 3 must be equal to L. So what is your fx? This is going to be this one, and what is your point is 2. So when limit x approaches to 2 of this function, this must be equal to 6. So this was the similar sort of thing there also. Now coming to the example number 3, here again we are given a function, it is given to be 1 minus x by 1 plus x, and x is given to be lying between 0 and 1. We have to find the real number delta which satisfies this condition. We have to find this delta. So again we will be finding this delta with the condition which is given to us, that mod of fx minus 1 by 3 is less than 1 by 10. So from there we will get the condition on delta. So again we are taking the function to be this, but this is important condition. We have to keep this condition in our mind. So when we will solve this mod of fx minus 1 by 3, these are simple steps, simple calculations. Finally we will get there at this very point. So here you can see that the x is lying between 0 and 1. This immediately suggests that 1 plus x should be greater than 0, isn't it? Because if x is greater than 0, then 1 plus x is greater than 1, and 1 is in fact greater than 0. So that means 1 plus x is greater than 0. Why I am saying this? Because I want to find out the mod of 1 plus x, since 1 plus x is greater than 0, and whenever we have any quantity which is greater than 0, which is positive or 0, then the mod is going to be that same quantity. So mod of 1 plus x is going to be 1 plus x. Also if you look at minus x plus 1 by 2, it comes out to be x minus 1 by 2. How you can see this? Because if you take minus common, then it's going to be minus times x minus 1 by 2. Now why I'm doing all this? Because minus 1 into x minus 1 by 2, that is mod of minus 1 into x plus 1 by 2, and you know that the mod of a into b is going to be mod of a into mod of b. So you can take that mod of minus 1 outside, and you will get another factor as mod of x minus 1 by 2. But whatever you have taken outside mod of minus 1, that will turn out to be 1. So you are left with only x minus 1 by 2. So that means you can write minus x plus 1 by 2 as mod of x minus 1 by 2. So that's fine. Now we want to find the delta such that this condition is satisfied whenever mod of x minus 1 by 2 is less than delta. That means we have to find the condition on mod of x minus 1 by 2 that we will get in the process. So if you look at this, we want this to be less than 10. We want this whole thing to be less than 10 for mod of x minus 1 by 2 less than delta. So this whole thing will be less than 1 by 10 if what happens? If this quantity is less than 3 by 40. Why? Because 1 plus x is what? 1 plus x is greater than 0. So this is greater than 0. What about 4 by 3? This whole quantity should be less than 1 by 10. So if we can put this mod of x minus 1 by 2 less than 3 by 40, then 4 tenths are 40, and we will have 3. 3 and 3 will get cancelled out. So what we will be left with? The whole thing will be less than 1 by 10. So, and this will be true for mod of x minus 1 by 2 less than delta. So mod of x minus 1 by 2 is what? This is less than 3 by 40. Moreover, this quantity will go this way. Maybe in the classroom I will explain it more, because in this open broadcasting software I may not be able, I don't have the feature of annotation. So I will clear this very step in the class, but you keep one thing in mind, that mod of x minus 1 by 2 is going to be less than 3 by 41 plus x whenever mod of x minus 1 by 2 is less than delta. So that means if we take delta to be 3 by 40, then we have mod of x minus 1 by 2 less than delta. That is, mod of x minus 1 by 2 can be replaced by 3 by 40. So if it comes to that, then mod of x minus 1 by 2 is less than 340 into 1 plus x, and that turns out to be the condition that we started with. That means whenever mod of x minus 1 by 2 is taken to be lesser than 3 by 40, then mod of fx minus 1 by 3 comes out to be lesser than 1 by 2, sorry, 1 by 10. That means the required delta that we were looking for is nothing but 3 by 40. In this video lecture, I'm going to stop with this, but you need not worry about anything. I know that the epsilon delta definition is a bit tricky, but in the class also I strongly feel that there are certain things in this very result, in this very example, which you might not be comfortable with. I am not even comfortable while I'm explaining it to you, because I don't have the feature of annotation which would have permitted me to explain those points, to highlight those points. So I am going to highlight those points in the class. So thank you so much.